we think about these different layers of the Earth, what is this really thin layer right here on the outer edge?
Isn't it the asthenosphere? I can't.
No. That's the crust. And then underneath our crust, Chris, is the asthenosphere. Okay, and that's spelled a little weird. You need to know how to spell that, asthenosphere. And what's the big red section, Hannah?
The outer layer?
No.
Intel?
The mantle? How about the mantle?
Mm.
The L.
You guys aren't perfect, so show
You guys, the L comes before the E, therefore there's an O sound instead of an L sound.
I know the other one.
Oh, okay, good. What's the yellow circle then, Hannah?
The outer
That's the outer what?
layer or shell?
Core.
Core. Then the inner core. Top of each
Peter?
to it. Inner core?
That would be the
Peter,
inner
I
core,
No, I said
yes.
it. I said it first. Outer's my inner.
Good job, Peter. Alright, so guys, this is basically it, right? This is our Earth.
Yay.
We have 5 basic layers. We go from the inner core to the outer core to the mantle to the asthenosphere, all the way out to the crust.
Into the air. Yay.
Now, what separates these? Why are the different materials in different locations? What's the really big separator here? Yeah. It has everything to do with this little thing.
Hey, Peter should know. Water. Yeah, Peter.
No. What are these doing?
Why don't you raise your hand, Peter?
Oh,
Hey, calm down. It makes me.
Why are they
Come on,
doing this?
Dad.
No. Density. Guys, the whole layering of Earth has everything to do with density, including our atmosphere. Actually has different layers based on the density of the gases in those layers. So we look at this layering, where do you think the densest material is going to be?
Oh, it's moving.
In the center. Okay, now I want you guys to think about this. If I get a material that's denser than this countertop, and I set it here on the countertop, is it going to fall through the countertop? No. So when did this layering begin?
Wait,
And
Mr.
what
Thomas, I have a question.
state would that material have to be in order for something to re-separate itself? Graham?
It would have to be like liquid, like water.
Yeah. Guys, if I had this as a bottle full of gravel and I just shook it off, what's going to happen to all the gravel pieces?
How's coming snake?
They're just going to mix, right? But the fact that it's in liquid, now they're going to separate based on their densities. That liquid allows them to have that vertical movement due to gravity. Okay, so when we think about density, density is being drawn apart because of the gravitational force. So we look at these different layers. Each one of these layers is more dense than the other. So the material in the asthenosphere is made out of chemicals or compounds or elements that are denser than the materials in the crust. Same thing for the mantle, then the outer sphere or outer core, and then the inner core. So it's really all about density. So our densest material, what is one of the densest metals? Use it quite a bit in building. Iron is built made out of iron. Okay. So yeah, so guess what our inner core is made out of? Iron. So we look at our inner core. There's 2 things I want you guys to know. First of all, it's completely solid. Diana, you need to be writing this down. Completely solid. It is. How many of you guys have ever seen a cannonball before? Yeah, they're not as big as they show on like cartoons. They're actually quite small.
Like Tom
But
and
it's
Jerry.
solid sphere, right? That's exactly what our inner core is like. It is this completely solid ball of iron. But it's not just iron, it's iron and nickel. So it's 80% iron and 20% nickel. And if you're looking at the radius of the Earth, so this is worth noting, the radius of the Earth from the center to the top of the crust is 4,000 miles. So out of that 4,000 miles, the inner core makes up 1,000 miles of that. And it's from this inner core that we get all the heat that fuels the inside workings of the Earth. All the heat is going to come from that inner core and work its way to the outer crust. Have we made it to the inner core before?
No.
So how do we know it's selenite? How do we know?
Like radio waves?
No. Radio waves, they're not going to make it 4,000 miles down and back. How do we know? Any ideas? Peter?
Like, can we do like X-rays of like of the Earth, but like?
Nope.
I'm trying to think of no.
No, we can penetrate the ground, but we can't get like super far into the ground. All right. So here's what I want to do here. Let's go to Google real quick, and we're gonna look up.
Meteorites.
Okay, I want you to look at this image.
It's a rock.
What is it?
It's a meteorite.
It's a meteorite. You guys ever seen a meteorite before?
A rock.
You guys ever had the opportunity to hold a meteorite before?
Why don't you give us the opportunity?
Okay. Tell me about it, Eric. It's heavy. What does it feel like? Yeah, it feels like solid metal, right? Okay. Put this into common sense. This rock managed to hit the Earth after coming through our atmosphere. What's happening as it's going through the atmosphere? It's burning up, right? You got a lot of friction from these molecules, all these particles up in the upper atmosphere. So what's left? Think about that. What's around this whole thing? If you think about it, this rock was much bigger than this. This is all that's left. Well, where'd the rest of that go?
Ask later.
I agree.
Or hit the X. Hit the X actually. Yes, Mr.
Okay, so where did the rest of that rock go?
It disintegrated.
Yeah. So what we see here is actually what?
A rock.
The core of that rock. So based on this, we understand that Earth is basically nothing more than a bunch of meteorites all condensed together, right? That's the accretion theory.
Right.
We can reason that from these asteroids or these meteorites that are hitting Earth, that what's left over is their inner core. So from that connection, we make the connection that our inner core must be solid. Yes.
I thought the accretion was with the moon.
No, that's co-accretion.
What's the difference?
The word co,
What's co mean?
together.
Oh wait. I was gonna say a co-worker, but that's working together. Don't give me that look.
Well, look,
That one you just gave.
I want to show